Alright, so today we're going to start out here with just a quick review. I'm not going to really go into this all that much. We'll talk more about it tomorrow in class. But I would like you to take a couple minutes to try this on your own. And that way you can compare your answers with what we get tomorrow. So today we're covering section 2.1. We unfortunately jump around a little bit in the book just because the ordering of the book is a little off. But today, 2.1, angles in the Cartesian plane. So we're talking about quadrants, axis, angles, terminating, so we're looking at where angles are going to start and stop. Talk about drawing them in the coordinate plane, so that way everyone worldwide does it the same way. So if one mathematician looks at yours and you look at another mathematician's, they're going to be done the same way. And then we're also going to talk about the term coterminal angles today. So since a circle is 360 degrees, we can divide it in half and half again to find the measure of each axis. So what I mean by this, if we're starting here, notice how this is 0. 0 is always starting on a positive x-axis. So if I go all the way around, I know a circle in degrees is 360, which is why I have that labeled there. Now, to kind of figure out what some of the other axes would be, I could cut that in half. And so half of 360, well, if I cut that circle in half on here, semicircle, half 360 is 180. If I cut it in half again, half 180 is 90. So each axis going up by 90 degrees. And also makes sense because all of these axes intersect at 90-degree angle measures. We know those are right angles. So if we're drawing an angle in standard position, we have a couple steps we're going to follow. First thing, initial side is always going to start here on the positive x-axis. The reason for that is on a Cartesian plane, that is always 0 degrees, or 0 radians when we get into radians. So because of that, the initial side, or where the angle measure initiates, has to start there. Then, based on whether the angle is positive or negative, we draw, either clockwise or counterclockwise. And then we draw it to a terminal side, which I have denoted here. So that's our terminal side, that's where the angle measure terminates. And then just to help someone who's looking at this angle measure, we want to make sure we draw an arrow in there. And that's important for the test because that tells me whether the angle measure is positive or negative if you don't have it written down there. So in this case, this is going counterclockwise, so this would be a positive angle measure. So let's look at a couple examples here. I'll do one, and then I'd like for you guys to try the next two on your own, and then we'll come back in class and see where everyone's at. So if we look at negative 118 degrees, so I'm going to come out here starting at 0. Now, which direction is it negative in angle measures? Is it that way, or is it that way? Hopefully, you know that it's going this way, that it is clockwise for negative. So we need to go in this direction 118 degrees. Well, from earlier we talked about this is 0. And we said each axis, if you're following an order, is an additional 90. So if we're starting at 0, the first axis is going to be 90. Technically this would be negative 90 because we're going in a negative direction. So if we're trying to get to negative 118, really, we can go here, well, negative 90, we need to go a little bit further. If we go to the next axis, this should be negative 180. Okay, negative 180, negative 118. Okay, that's way too far. That's way past negative 118. So we really have to go out to about here. Now, we're not using protractors or anything to draw this. Instead, we're trying to do, just to give you an idea of how to draw it out, not necessarily to scale. So here, our final measure, our final picture would look something like this, where you would have negative 118 degrees, whoops, almost drew that wrong, negative 118 degrees, starting in the initial side, being measured clockwise to approximately there to our terminal side. So like I said, I'd like you guys to try the next two on your own before coming into class, and we'll go over them in class time. Alright, next main idea we're talking about today is coterminal angles. By definition, what coterminal angles are, they are two angles in standard position, meaning they're starting with 0 down here on the x-axis, if you look where I'm drawing there, with the same terminal side. So that means they don't necessarily have to go in the same direction. They just have to start and stop at the same place. And since angle measures can loop over and over and over again to go above 360, that gives you an infinite number of possibilities where you could do this. So if we're looking at, for example, 300 and negative 60. So we're starting here at 0. Well, we know 360 is all the way around if we were to go all the way around the circle to here. So we want to go 60 degrees less of that. Well, here, this is 270. So 300 is probably going to be here somewhere. So then we draw our arrow. And this is how we got 300 degrees. Now, negative 60, we're going to start here again as well. But we're just going down 60 degrees. So it's going to come down that direction, clockwise, and it's going to stop at the same place. So those are coterminal because they start and stop at the same place when you're measuring these two angles. We look at the next one. Let's look at 385 and 25. So starting here, well, we know that is 0 and it's also 360. So 385 means you're going to be here, 360, and still have another 25 degrees to go. So you're going to pretty much stop there, which I know is kind of a weird concept. It's just something you have to get used to. Now 25 would start at 0 again, but it's just going to go over there as well. So it starts and stops at the same place, with the difference being that you didn't do one full revolution to get there. So what we're going to look at here, two ways you can do this. One is you can draw these pictures and kind of figure it out, you know, just by reasoning. The other way you can do is you can add or subtract 360, because remember 360 and 0 are the same thing, because 0 starts here, and if you go all the way around, you come to the same point again in 360. So you can just add or subtract 360, and that will keep your terminal, you know, your terminal angle, or the terminal side in the same place. So you can add or subtract 360 until you get what you're looking for. And typically, since there are an infinite number of possibilities, you'll be told something like, you know, the smallest possible positive, or something of that sort. So here, smallest possible positive measure that is coterminal with the following. So once again, I want you to try the last two on your own. We're just going to do one here together, and then we'll come back and look at those later. So if I'm starting at negative 520, well, I want smallest possible positive. That's obviously negative. So to make that positive, I'm just going to add 360 to it, because that's going to get me closer to positive numbers. So if I add 360, I should come up with, hopefully I'm not terrible at math, negative 120. Now it's still negative, so I'm going to have to add 360 again. That puts me at 200, hopefully. Now that is positive, and it's the smallest one, because if I go in order, I started at negative, I started here at negative 520, then I got to negative 160, then I got to positive 200, so that would be my answer. So that concludes the notes for today. Like I said, try these other examples on your own. If you don't get them, don't worry about it. We're going to be talking about them in class.